transfer. Diba? So, introduction. What is heat transfer? So what do you mean by that? So we need to scrutinize. The first term is heat and the second term is transfer. What do you mean by transfer in English? So you need to move, you need to transport from point A to point B, right? So there's movement. So we are referring here to the heat that is being transferred. Normally, the heat really involves molecules. Okay, so what we are referring here is the heat energy of the molecules. Okay, so all substances have its own molecules. That's why the heat is being transferred from hot environment to cold environment. So our driving force here will be the change in temperature and the temperature gradient. Okay, from final temperature to low temperature, something like that. So if we talk about temperature changes, usually it based on how endothermic and exothermic the process and the system really is. So we need also to account and to remember in general chemistry lecture the principle of exothermic and endothermic. So it's very necessary. Okay, so that we can, oh my gosh, so we have an enthalpy, entropy, internal energy, something like that. Okay, so we need to do that. Okay, so going back. So we have three types of heat transfers. The most common is the heat transfer through conduction. So this is a transfer of the heat energy molecules, okay, through solid medium or solid substance. And then there must be a movement of the molecules, okay? So solid siya. For example, sugar, like that, and then the glass, something like that, okay? The water and the glass. Okay, for example, if you pour water in the glass and the water is very hot coming from the kettle, and then the glass will become hot. So the heat is being transferred already for that in our daily lives. Dili-dili alatul when you make coffee. Okay, not only that, for example, I off my AC, but then after this, I will on my AC. So it's gonna be a bit warmer because I don't want cool too much because I cannot survive. That's why I off the AC. Okay, but then when on that later on, it will become cold also. So there's a transfer of the temperature from higher temperature to low temperature. Ganun siya, in fairness, di ba? Di ba sa yun ra siya? Thermal equilibrium, ganun, di ba? So solid substance. The heat transfer through convection is the heat transfer that based on the movement of the fluid, liquid, and the gases. Okay, the movement of the molecules of the fluid, liquid, and the gases. So there's no solid involved. Okay, here. And the last will be the heat transfer through radiation. Okay, so example, the heat of the sun, something like that. So it radiates. The radiant heat of the sun radiates to the planet Earth. So that is an example of heat transfer through radiation. So this is the time we will use the Stefan-Boltzmann law. Okay, you get the point? So sabi ng Stefan-Boltzmann sa Sotero, charot, okay. So muna siya katong na mga emissivity. Yeah, did you remember that one? Emissivity times, mag-time siya sa mga ano, ito. Okay, unahon ko ang heat transfer to radiation ha, kaya marag unique man siya. So, heat transfer through radiation is gonna be Q, that mean heat, or actually it can be written also as delta Q, delta T, heat transfer, rate of heat transfer, or rate of heat flow. Pareho ra siya. Or rate of heat transmission, something like that, or rate of heat transport. Okay, so it will be the same, only English matters there, vocabulary. Okay, heat transfer, heat transport, heat transmission, something like that, heat flow. Okay, so mag-usab-usab siya during the discussion in the books, depending on the chapters how he or he discussed the terms they used. But normally, it is heat transfer, rate of heat transfer talaga ang pinaka-common of all. Okay, but in physics, we don't use transfer. We use, rate of heat flow, like that. Heat loss, heat absorbed, like that in physics. Because generally, this coming from physics also, the heat energy. It's being discussed there also. Apart from it's being discussed in chemistry, general chemistry lectures, being discussed also in physics so many times. Okay, because as I told you, physics is a branch of science that deals with the study of matter and energy. And heat is one type of energy. Get the point? Something like that. And matter is anything that occupies space and has mass. And this is specifically the liquid, the gas, and the solid. That's matter. Okay? So it's in physics are being discussed there, blah blah blah, the physical properties, and then in the chemistry, the chemical properties are being discussed there also, the chemical reactions. So it's not more on physical change in physical movement. In physics, more on physical change in physical movement from the word itself, physics. That's why it's physical. The root word there is physics, physical. Okay, physics. In chemistry also, chemical change. That's why chemistry or like that. There's a word CHIM, chemistry or chemical. So ganun siya. You have to troubleshoot the terminologies, so that you will never be confused. Okay, Q is equals to the emissivity. What do you mean by emissivity? Okay, what you ko kinumdaman sa college, but based on my research just 2 days ago, ambot lang ka kung nakalimot ba ko ni ini, but I don't really, memorize this before. Emissivity, really. So emissivity is a ratio of the radiant emitted. Okay, the total actual radiant emitted or radiation emitted over the total black body in radiation emitted. Black body, you know the study of black body in the outer space like that. Okay, muisgot na sa taan nila ni Kuan Max Planck, ganun. Muisgot na hula. Okay guys, muisgot na sa taan nila ni Max Planck. Okay? Muna may tabo karon. But, so dila sa tamis ko tanaw, okay, ingon ra ko ninyo na mo na siya emissivity. Okay, the ratio of the total actual radiation emitted over the total radiation emitted by the black body. So that's emissivity. So basically, emissivity is gonna be unitless. Okay, there's unit because the numerator is about radiation emitted, and the denominator also speaking about radiation emitted. So technically, there's no unit, so unitless. Okay, so it's gonna be the value is from 0 to 1. Okay, kung mula pa siya sa 1, dili na siya emissivity. You get the point? So ayun na siyang gamitan nga formula. If the emissivity will be more than 1, ay ipugos. Because in this Stefan-Boltzmann equation, the emissivity must be less than 1 within the range 0 to 1. Okay, so muna siya natabo. So emissivity, okay, ganun siya. Okay guys, emissivity times, kanang ana ba, kanang circle bito nga marag ni ana, niya sa symbol, Greek symbol, kanang ana ba? Di mo sa di siya phi. So tawag ani, di ba phi, theta, omega, rho, delta, kani siya sa man ni siya. Basta mo ni siya ha, muna siya ang kuan. Stefan-Boltzmann constant. Okay? So ang yang value sa Stefan-Boltzmann class kay katong 5.67 times 10 to the negative 8. Okay? Nya watts, meter squared, then Kelvin raised to the power 4. Oh my gosh! Very unique. Kelvin raised to the power 4. Okay, this is the constant ha. So I introduced another constant so far. So this is the constant of Stefan-Boltzmann constant. Not the same with the Ludwig-Boltzmann constant. Remember that one also ha. I confused kay. Imo itong gamiton ang Ludwig dire ari di siya ma-apply. Only the Stefan-Boltzmann constant. 5.67 times 10 to the negative 8 watts per square meter Kelvin to the 4. Okay. Now since watts, okay, is the unit of power, okay, in electricity, right? You remember that one? So watts is also joules per second, something like this. So joules per second. So it is expected to be that sometimes these watts will be lost in the unit of this 5.6. But don't be afraid, it's still watts. Okay, for the purpose only that it should be break down to parallel with the other unit beside this kani siya nga murag angle, usan siyang angle sabot. So Stefan Boltzmann, kasi tawag na niya, basta mo na siya, tanawa lang ninyo. Makakita ka naman nga nga symbol, mo na siya ang Stefan Boltzmann constant. Ha, kay nakalimot mo ko sa pangalan. Okay? Times emissivity. And then times area. Nakakaloka. Area. Times capital T raised to the power 4. See? T raised to the power 4. Meaning to say, makansel itong denominator sa kuan. Sa diri, di ba? Sa Stefan Boltzmann constant. Key force sad siya. Di ba? Maro kayo. Okay. So, equation of a radiation through radiant heat of the sun, heat transfer through the theory of Stefan Boltzmann is emissivity times the Stefan Boltzmann constant. Ganunin lang natin. Stefan Boltzmann constant times the cross-sectional area. It depends on the situation if it is a pipe or it is a sphere. It depends on the shape you are dealing with. Okay, it could be rhombus, trapezoid, rectangular. Okay, depende mo guna siya ang pagkuha sa area. Di man maglimit lang sa circle. Okay, not all baya ang mga agianan ng mga liquid, puro siya circle. So, mo gamit tag pi r square, dili siya sa tanang panahon. Pwede sad mo gamit atong length times width. Okay, kung rectangular lang yun siya. And then kung square siya katong s squared, sides to raise to the power 2. Kaya equal man ang tanang sides sa square. Nya kung kuan naman pud siya kung sphere mo tumo 4 pi r squared ka sa area. 4 pi r squared is the area of a sphere. Okay, am I correct? 4 pi muna siya kung hinumduman 4 pi r squared. Sphere. Okay, panagsaraman, it's very rare to use other shapes for this. Okay, it's always pipeline, magandang siya, diameter niya kay circle gyud siya kasagaran or let us say square. Okay, ganun. So, panagsara gyud kay siya mo gamit og mga lain-laing mga shape. Okay? Kaya di man siya common ang mga rhombus, mga trapezoid, pero we don't know really to test the intelligence of students or the examinees. In the problem solving in the future, they will give something like that. Also, then memorize also the area and the volume of various shapes. To the point, not limited only to square, circle, and sphere. Memorize also the area and volume of a rhombus, area and volume of a trapezoid, area and volume of an isosceles triangle. O, di ba? So, sa itong area sa kuan, sa triangle, di ba? 1/2 base times height. So, ganon. So, i-think sa di mo nga, nasa area ang mga isosceles, acute, obtuse angle. Diba? Obtuse angle, obtuse triangle, right triangle, and acute triangle. So, troubleshoot if it has the same formula also because the basic formula of area for the triangle is 1/2 base times height as far as I could remember. Okay, and I don't remember oblong. There's an area of the oblong because oblong is an improper shape. Really, that's not standard shape. You get the point? The oblong. The oblong is just like an ellipse. Okay, so meaning there's no such standard for area of volume for that. Okay, muna ako natiman-an basta oblong o kaning ellipse o shape permanente. So ang ellipse mo gamit siya sa kuan sa circle nga area o volume. Okay. Round man po siya, pero kuan siya pinatalinis. Pero what I mean, this oblong and, ellipse, what siya kagalingong formula. Okay? So, i-research ninyo kung naa, then tell me. Okay? Area of an oblong. Ganan. Volume of an oblong. Diba? Nakakaloka. So, naman sa tayo volume of katong length times width, volume of a cube. Okay? Length times width times height. Okay? So, gamit kaya na siya, volume, length times width, a cube, an ice cube. Okay? Gamit yung kaya na siya, pero na siya balik-balikon sa mga problem solvings. Okay? Ang cube. Okay? Then, x to the 3 na yun, kaya equal ba ang cube? O, ganan. So, dx, ganon na yun, integral, differential, o limits from x1 to x2. Ganon siya. Okay? Timanin na lang. Okay? Emoji na buhaton. Wow. Okay. So, mo ni siya ang atong formulang gamiton karong higayon na. Charot. Okay? So, heat transfer through radiation is equals to the emissivity times Stefan Boltzmann constant times the area, could either be surface area, could either be also cross-sectional area. Cross-sectional area kung circle or pipe, but surface area kung square or rectangle. Okay, times capital T raised to the power 4. When we mean capital T, guys, put that in your brain cells that this capital T is always Kelvin. Okay, so if the temperature given in the problem solving in the future or in your examination now, whatever, okay, Celsius and Fahrenheit, convert that to Kelvin. Okay, so Kelvin is equals to Celsius plus 273.15. Ano maluluka ka kay Fahrenheit man ang gihatag. So, i-compute sa mo ang Celsius formula gamit ang Fahrenheit. So, mag-convert ka ay sa ipasok ang kanang mga Celsius, mga Fahrenheit diretso ani nga formula. Ang capital T is Kelvin baya. So, marong jud ka for sure. Okay? Ganun. Pagdali-dali. Okay, iimo siyang i-polished before you substitute to the formulas and equations. Ganon. Asa naman ito akong problem, guys? Kaloka. So, I have to get my problem na... Asan ito kung isuwat? Wait. Andiyan na naman tayo. I have so many problems here. Right? See? I have so many problems here. I'm not a student anymore, but still I have so many problems here, problem solvings. Okay. Oh my gosh! Ang tangkang jud siya, pero later na ako ikon. 3A. Question number, Question number 31. Problem solving number 31. Sphere with emissivity of 0.42 of radius 25 centimeter is at 27 degrees Celsius. It is placed, oh my gosh, in a room with a temperature of 21 degrees Celsius. What is the rate of heat energy leaving the sphere? What is the heat energy that enters the sphere? How long will it take for the sphere to lose 1 times 10 to the 6 joules of energy? So, murag lisod siya kayo kung wala tayo idea, di ba? Mismo ako, naglisod ko nagtanaw karon. Wow! Okay? So, dapat i-familiarize din mo siya nga, mauday ni siya, para dali na ka-isip. Okay, so mag-isgot ko na siya emissivity, guys. Bingo! Kung ano gina siya? Radiation of heat transfer through radiation. Hati man Okay, magawas din ni siya. Okay? Saguhin din mo na, heat is equals to emissivity times Stefan Boltzmann constant times the area times capital T temperature raised to the power 4. Ganun. Okay, mura na siya mubaton. Okay, muna na siya, no? Kaloka. Wait. Okay, guys. So, mag-drawing ko sphere. Kasi ko rin ng sphere, di ba? Okay, so itong technique, write what is being asked. So di lang ako i-write, ikapoy na ka-i-write. Basta mo na lang ni siya, heat energy. The Bluetooth device is ready to pair. Heat energy of the heat energy of the sphere. Okay? Okay, madugay man ta, guys. Okay? Charat. Diba? Uy, what you ko kayo nung dumani doon, nag-solve ko, ani. Really? When I was in college. Wala kayo ko hinumdum ani. Amo to natugro siguro ko pag-discuss Okay. Karon pag ko kibaw nga nadin ning ani 5.67 10 to negative 8 watts per meter square kina kuan constant sa kuan sa unsa ni siya Stefan Boltzmann. Medyo kibaw ni sa una. Okay? Sige lang. Okay. Kabaw naman ko karon that would matter. Okay? So, we have a sphere. Muna siya tulo, 3R ask. So, padayon na lang tanong. So, what is the rate of heat energy? Okay, number 1. Rate of heat energy. Heat energy. Guys, ayaw yung kalibog na may mga usahay nga rate of heat energy cure na siya kay gi-assume man guna siya nga ang temperature ang time is constant. So the time will not matter at all. But then, ang pangutan, di ba, kasabot man ang rate ng G times sa denominator. Assuming maguna siya nga ang temperature, ang time constant. So not necessarily nga, ituki mo, ni mo pa na siya nga, wala na ka nga, what is the heat energy? Nadyo siya rate, kay understood ba na siya nga, delta Q, delta T. Assume naman na siya nga, wag siya time reference ba? Okay? Constant ang time all throughout the process. Dili siya mag-take factor ang time. But still, delta Q dt mo nang dili na siya butangan nato og dt ang dinamit ang Q. Mibong yung no man T so tingon biya ka ang rate na unit times sa denominator. So di man ingon nga permi gyud nga word for word good kanang imong sabton ba nga ana siya constant. Okay, steady state man siya. Okay? Ganun siya. And then number kuan, diba? Leaving the sphere. So leaving the sphere, the rate of heat energy leaving the sphere. Atong sabton ha. Leaving the sphere. So leaving the sphere, if we treat that a sphere is a system, the room is the surrounding. So since it leaves from the sphere, it's gonna be there's a heat released from the system, or the heat released from the sphere. So it's gonna be exothermic reaction, that it releases heat to the room or to the surrounding. So exothermic. So when we mean of exothermic reaction, it has a negative enthalpy or negative heat content. Okay? Always like that. And also negative delta G. Okay? Meaning spontaneous. Okay? Or reversible reaction. Okay? What we mean, it will just continue by its own, going back and forth without adding anything, without doing anything, whether physical change or chemical change. That's a reversible chemical reaction, spontaneous, and exothermic reaction. Okay, ni-release man siyang heat. Now, kung we talk about the room, which is the surrounding, okay, nag-absorb siya ang heat from the system or from the sphere. So that's gonna be endothermic sa parts sa room. Okay? So, delta, sa part sa room o sa surrounding, ang delta G niya is non-spontaneous. So, positive delta G and positive heat content. Kaya nag-absorb man siya. Okay? So, dapat sabto na ito sa inahitabo. Okay? Ganon. Okay, so, number 2. So, what is the rate of heat energy for the sphere? Absorbed ba? Rate of energy of the sphere. Kani makalibog po din siya ha. Tanawa ra god energy of the sphere. English ni siya mga preposition of, from, to, mag-matter siya sa question. Tanawa ha. Okay. Rate of energy leaving the sphere. Of course, ni-leave siya sa sphere. Ay, kadang question, rate of heat energy for the sphere. Unsa man ang for, di ba? Preposition. Kauban sa mga of, for, to, and, but, under, near, underneath, below. Okay, mga prepositions in English. So when we mean of for, that is going to the sphere. Okay, for man siya. Okay, so see, what is the heat energy for the sphere? So meaning, the sphere will absorb the heat of the room. Bali na ni siya. Atong question na aning usa, what is the heat energy for the sphere? Okay, bali siya atong first nga, rate energy leaving the sphere, ni-release man siya. Okay? And then number 3, how long will it take for the sphere to lose? Okay, this question number 3 is very tricky. Okay, because if you use the radiation of heat transfer, there's no time involved there in the equation. And then the students also will be shocked asking for the time. You got the point? Because normally, when the instructor discusses this, the sample problems at first don't include time. You get the point? Now, if you are a very resourceful student, you go to the library and there's a lot of examples there, you will meet kinds of problems. It's an advantage. And now, if you will not go to the library, you just depend to the instructors, the sample problems are just limited. When midterm coming, prelim coming, final coming, you will be shocked that it looks like for you difficult because it never asked during the example. But actually, that's not difficult. It's your fault. Okay, you did not go to the library, you did not research more because time is related to this, something like that. Okay? So, di na to i-blame sila because it teaches us to be resourceful and to be initiative. But it would be okay also, plus na lang siya or bonus, nga ang instructor, muhatag gid siya mga mutuki siya mga lain-lain mga quantities, madili lang kay sa example sa books. Okay, ika midterm ba ya o ka prelim ba ya, muhatag ba siya kanang dili, wala niya gikuan dito sa problem. Example ang problem ani niya no, heat transfer, emissivity, 18. Mukalit like ingon nga, what is the diameter of the pipe during the heat transfer? Ganun, layo raman to sa iyong discussion. Okay, wa ba siya naabot atong i-compute ang diameter? You got the point? Now, kung clever ka, labi tayo mga mass flow rate, mga volumetric flow, gamito na ba ito niyo niya? Imo din i-connect ang mga kuan. Bisa kuan niya gi-discuss, hala, ipasok. Basta as long as it is technically correct, precise, and logical, something like valid to certain conditions, you take into account the proportionality and the parallelism of quantities, mag-ratio and proportion ka, oh my gosh, gonna be like this. Okay, so do not limit the, on the examples of the instructors, okay? It's gonna, or for your teachers, go beyond that. Okay, that's a technique, ha? Okay, to pass certain examinations in the future, you have to exceed the limits in your classroom. Okay, go out from the backs, not only in your classroom discussion. Go to the library, okay, ganon siya, or go to the online, ganon, na medyo need pa further understanding. Okay, because there's a lot also vloggers from United States of America, especially the Harvard University, okay, Department of Physics, Chemistry, University of Michigan, something like that. Sometimes I will watch also their videos. Okay, Toronto University, something like that. So they have also another attack of how to solve the problem. So because sometimes also our instructors are very traditional and conventional, referring only to the books that were created in 1970s, 1960s, and that's already very long time ago. And then the presentation of discussion is not that really very clear to the students. The attack on how to solve that. That's why mumatter na siya the way how the instructors deliver the discussion. Okay, the content of the discussion of the instructors, because pareho naman gid siya tanan. Okay, the subjects physics are the same also. The physics in the Philippines is just the same the physics in the United States of America, in India. Pareho ra gyud na siya, it's just the same. It matters on how the instructors deliver his or her discussion. Okay, it's gonna be like that, how they teach the straightforward technique and strategies to solve very well the problems. It's up to them also, but as what I told you, it's not enough. Okay, you go to the library, research chuba chuchu, and then make it advance, something like that. Okay, mo man akong ginabuhat sa una. Okay, ako lang yung gi-share. Okay, I want to share this to all of you guys. Okay, that's gonna be like that. Okay, nga kuan mo na siya nahitabo mo na mo feel talo lisod lagi kay examination. Actually di man na siya lisod. Okay, walang nato masugati ang mga ubang mga kuan diyan. Okay, connect dito. Okay, muna na siya ha. So time of the sphere to lose the heat energy. Ang sphere mo lose man yun siya heat energy, di ba? To the room. Ganon. So, muna itong mga given. So, sphere emissivity of, kuan siya guys, 0.42. So, muna siya. Emissivity 0.42. Stefan Boltzmann constant is 5.67 instead negative 8 watts per square meter, degrees Celsius. Or it could be joules per meter second Kelvin. Mugamit ta og second ani nga unit because of the time ang god ani niya. Nag-involve na mag time ari sa question. Okay? Ganon. So you should remember guys that watts is equals to joules per second. Okay? So like that, and 1 horsepower is equals to 746 watts. Okay? Now, if the problem asks is given in the problem is horsepower, they don't mention the, the watts there and the joules, then you have only the idea, oh my gosh, I should convert this to the unit of energy. O, ganon. Because horsepower is not common as a unit of energy, but actually that is power energy, electrical power energy. The same with the joules, okay, the erg, the BTU, the British thermal unit, you know that one? Something like that. So it's still an energy unit. Okay, di lang siya permi ginagamit kaayo, but it is an energy unit. Okay, that's why watts is equals to joules per second. Ganon. So 1 horsepower is equals to 746 watts. Okay, ganon. You got the point? Something like that. And 1 calorie also is a unit of energy. Be careful. Because sometimes also, calorie will be involved here. Though calorie is a unit usually expressed in biological substances, in biochemistry, most of the time, like that, in biosynthesis inside our body, okay? But sometimes also they will use calorie in these questions. So this is not limited. Expect the unexpected. Sometimes you will use calorie. So 1 calorie is equals to 4.184 joules. Then joules to horsepower, joules to watts. Oh, bingo. Makuha jud ninyo. Okay? Ganon. Basta ka mauta sa conversion factor. So from now on, memorize the most common conversion factors. Especially if you are taking engineering course. Okay? Got the point? Because ato na siyang data to use the conversion factors always in our engineering major subjects. Okay? Ganon. So, ang saan naman ito pag-attack? How can we have an attack of this problem? Okay, mag-draw na ta. To further illustrate, we need to draw the sphere. Ganon. Pero kung master na dyan ka, if you are really master how to solve it, then you don't need to draw or to illustrate. Okay, but if you are trying to vlog like this, to share the information for the purpose of discussion, then you have to illustrate and to draw. Okay, because you have audience. Okay, something like that. Okay, get the point? Sometimes also they cannot get what you are trying to convey to them. Okay, something like that. So this is a sphere. Ganon. Sphere. So the temperature 0.42 of radius and radius of ito na sa siya kabuang radyo kayo nila no. So radius 25 cm. Ang radius guys sometimes it should be also used as a thickness and a length. Be careful to that also. Okay, sometimes man good it's gonna be like that, especially if that is pipeline. Sometimes you'll also say the length of the actually they are referring to the diameter, they are referring to the radius. Not all the time radius they will say, because the length of the circle or diameter is just also the length. Okay, but they will never express that in diameter word for word. Sometimes they don't expect also from radius, but sometimes they will just use length. The length of the pipe, the length of the cross sectional of the pipe, like this. Di ba nasa pipe ang gitason, but that is another case. They will use the length of the the circle like that, but actually they're repairing the diameter. Okay, it's not the length of the pipe. Maro kayo lagi sometimes guys like Bernoulli theorem, like Reynolds number. You know Reynolds number? Velocity times density, velocity times density times the viscosity over velocity times density times the viscosity over the length ba? Kasi nga ang length diha kay diameter ba ya sa katong cross sectional area sa pipe. Dili ba ya dimension ang diameter di ara, maro lagi kayo. Okay? You got the point? Something like that. Okay. Ang diameter ani nga circle kay length man gyapon na ani nga kuan god opening. Muna maingon lang siya L, but actually that is diameter. So ana nang pag-discuss sa mga instructor, velocity times density times the I'm not really sure kay wala ko jud siya na butang sa akong brain cells, but it's gonna be velocity density times viscosity over L. Okay. Or it's gonna be basta magrambol-rambol na siya kay gimemorize naman to nako siya. Basta mo na siya metabo. If I'll have to scrutinize the unit, then makabaw ko pila jud pero wa man sa unit ang Reynolds number. Right? Reynolds number is unitless. So it's very difficult to troubleshoot. Okay, but if it cancels also all, then you can say, this is the equation. Okay, so it's gonna be like, nakalimot man ko, di ba? So, niana ko nga, density times velocity times the viscosity over the L. Pwede man sabihin, ana ko, viscosity times density times L over the viscosity. Kaya di man ko sure, akong butang ang tagsag unit, kung makancel ganito siya, mawala na siya unit, kaya unitless man ang Reynolds number, so that could be the formula. Mo na siya another technique if your memory fails. You get the point? May anak ko sa una pod, makalimot gani ko, ipangsudin ako ang mga units. Tuk, cancel. Kung ano siya, nabali. Ganan. Di ba? Kasi sometimes, mabali hindi ka memorize. Sure. Sometimes, labi na ka nalisod jud kaayo. Sabto na to, yan naam jud times kad nga, if you study chemical engineering, sometimes times nga di jud ka kasabot nga marag, maglibog jud ka pag-ayo kay mga molecular na, okay, something like that. You never see in your naked eye the movement of the molecules. Oh my gosh, the vapor, and you studied it very well. So you can only just imagine, but you can never touch or you can never see. Okay, that's the difficult thing in studying things like that, in which you don't see. Okay, you don't touch. Okay, how can you touch the proton? You never touch the proton and the electron, and you never see them in your naked eye. But chemical engineering is studying that very much from first year to fifth year. Okay, nakakaloka. Okay, that's why in energy time, if we memorize formulas, sometimes we will, or say, we will forget. Just like this, I forget the formula of the Reynolds number. Okay, but I think the length is in the denominator. I don't have to prove because that is not our topic, right? Our topic is heat transfer to radiation via good siya. Okay, so muna siya. Sarap. So, radius and 25 centimeters. So, radius meaning half radius siya. Okay, 25 centimeter o dala siya o radius. Ganan. Diba? Radius. So, R siya. Okay, radius man. Okay. And then, 27 degrees Celsius is at 27 degrees Celsius. Ganon. So, 27 degrees Celsius ni siya. Okay. And now, a room temperature, nasa gawas ang 21 degrees Celsius sa room temperature. Diba, niingon ako ninyo na ang room temperature is arranged between 20 to 25 degrees Celsius. Okay? Like that. Okay? I have to share with you. I read last 2 days ago the thermal conductivity of strawberry. Wow. Kaluka na to. The thermal conductivity of strawberry is closer to the thermal conductivity of water. Meaning to say, the strawberry will conduct electricity. Strawberry, the fruit. It is closer to 0.598, which is the thermal conductivity of water at 20 degrees Celsius. It's basically closer to that. So be careful, strawberry will conduct current or electricity. You got the point? Kaloka, di ba? Okay, so the higher the thermal conductivity, the lower the resistance. That's why if lower resistance, so this is conductive. Okay, now, if you talk about the insulator, it's the reverse. Okay, the thermal conductivity is lower. Right? So there's a lot of resistance there. So it will resist. It will never conduct too much electricity. So that's why insulators have a very low thermal conductivity and a very high resistance. You get the point? So you will get the relationship all somewhere along the way. Okay, but it's very clear also for the term alone, the thermal conductivity. Even though you will not memorize, you can say, higher conductivity, because the word itself speaks for the term of thermal conductivity. No need to memorize that, higher conductivity, higher thermal conductivity. Of course, it is highly conductive because that is thermal conductivity. Okay, so ang imong problema ho na lang ang usa, ang resistance. Since you know the formula, in practical electricity, that resistance is equals to the length over the thermal conductivity, so inversely proportional siya. Then kung mutaas ang inyong thermal conductivity, increased thermal conductivity, meaning to say your resistance is very low through the relationship formula of the resistance. So resistance class in heat transfer is just the same with the mass transfer, but it was exchanged only with another term, which is the mass diffusivity or diffusion coefficient. Okay, it has another unit, but what I mean is just the same. It's in the denominator and it's also constant like that value. So D lang siya, kay diffusion coefficient. Ang thermal conductivity kay K man siya. Okay, so mo lang gyapon ang formula niya ha. Ganon. Okay, going back. So, 21 degrees Celsius. How long will it take? Gamito na yung formula kani siya, guys. Okay, Heatman. Ganito. So, Q is equals to emissivity, 0.42. Substitute there. Actually, direct substitution lang siya, but it looks like the problem is very difficult. Okay, because it's not familiar and popular to deal with this because this is the third part of heat transfer. Usually, when in college, admittedly, the most discussed part are the heat transfer through conduction and heat transfer through convection, convective heat transfer. But we talk about radiant heat of the sun or radiation, it's not really that discussed well. Maybe it touched only in the theory, but for me, as far as I could remember, wala siya mga problem solving. Okay? So, siguro natulog lang or whatever, but that's what flashed back in my brain. Okay? Wala siya mga example kayo ng i-deal ang heat transfer through radiation. Okay? Like this. So, emissivity, 0.42. Okay, ganon. Then, Stefan Boltzmann constant. But, admittedly, sige ko kabasaan ng Stefan Boltzmann constant when I was in college. Really. But, wala sa dyan ko ni ko asa mo gamit niya hangtod di graduate na lang ko na chemical engineer na lang ko until now ay mao din siya. Imagine I'm already a registered chemical engineer and just now I know that the Stefan Boltzmann pala ani siyang equations. Meaning to say there's a lot of things I need to know. Okay, even though I am already a licensed chemical engineer, I still a lot of things to know regarding the field of chemical engineering. Okay, so kung man jud kay siya broad, grabe jud kay siya ka. Okay, basta. So 0.42. Na nakakaloka di ba? Okay, so times Stefan Boltzmann constant na 5.67. Okay. Malay mo ni absent lang ko ato, gidiscuss ni siya. Okay? So ato siyang i-breakdown ang watts per squared meter and Kelvin for ha. So, it's gonna be like this. Joules second, then meter squared, K4. Okay? Then, temperature niya, guys. Guys, delta T ni siya. Now, I'll teach you something. Okay. If you're taking up engineering course, you should be careful. Okay? What is delta T and T alone? Okay, T alone. The equation here is T alone. So do not sum the temperatures and do not take the difference of the temperature because it's not difference. It's not gradient. It's here. It's only temperature, meaning you are going to substitute only the value of the temperature. Okay? Kaya uban, maglibog na, sama na ako sa una, okay, utro pa kong libugon, okay, I will substitute, mag-subtract na yun ko, but not knowing that this is a T only. Okay? Meaning, this is not a temperature gradient, this is not a temperature difference. Okay? It's only the value of the specific, what is being asked. Okay? So, T. Na namatay T sa sulod sa sa sphere nga 27. O ganon. So, ganon siya. Tricky ba siya, guys? Though this is directly substitution, but tricky. I will teach you later on. So, 27 degrees Celsius plus 273. Guys, 273.15 mo na siyang ipuno sa Celsius, but never add that to Fahrenheit. Convert first the Fahrenheit to Celsius before adding 273.15. Kaya lahir na ba siya formula? Okay? Fahrenheit and Celsius, different formula. So be careful. Do not add directly the values of Fahrenheit to 273.15. Now, you should be also careful. Some books are using 273 and other books using 273.15. Now, in my part, just include the 0.15. Okay, because that would be totally precise. If you don't include the 0.50, maybe there's lacking there in the choices. It's very near choices. Matay ka. So marong ka kaya ang choices close na kayo. For example, A, 27.12. B, 27.11. C, 27.13. Oh, wala na. Kaya mong gi-substitute ang 273. Naanad ba mo sa ang uban mo substitute og 273 ra gyud. So i-incorporate gyud ang point something. Because we don't know in the choices, okay, very close lang siya. You get the point? I-carry yun ang point something, ha? Okay, when you do the substitution. O sa mga example natin niya, for example, acceleration due to gravity, 9.81 meter per second squared, o ganon. So, density, 62.43 pounds per cubic feet. I-appeal yun ang point, 43, ha? Okay, ayan yun putla kay inika choices baya, no matter baya gina siya. Okay? You got the point? Mo sa ni ang Kelvin. Kay sometimes man good, ang uban mo use og siya 273 kay murag negligible gyud siya kasagaran, but then be careful also, who knows that choices are very closer. Okay? So duha ra bitaw nakabuok 0.1 ag 5 ra di appeal na lang na siya sa computation good. Okay? Diba? So, it's gonna be Celsius, degrees Celsius plus 273.50. It's just like in the issue of the bar. You know? 1 bar is equals to 1 atmosphere. You remember that one? But the precise value of that is 1.013 bar is equals to 1 atmosphere. Since that is very close to 1, naging negligible na talaga siya. But be careful also in the, you know, the choices. Okay, that's why I'm using always 1.01 bar, 1.013 bar before, even in my college days. I'm not using 1 bar. Okay? Again, do not use 1 bar always equal to 1 atmosphere, though it is nearly equal, because sometimes future examination will give choices that's very, very near. Okay? So you have to go back again to solve because you did not include the 0.013. You got the point? Okay. Another example also based on my memorization. The vapor pressure of water at 25 degrees Celsius is 23.80 torr. T-O-R-R. Okay. So do not run off also 24. That is 23.80. Leave as that also. Even though that is 0.8, leave. So that is 23.80. Do not round off. Okay? And in terms also of bar is 0.0137. I memorized that. Okay? 0.0137 bar equivalent to 23.8 torr. Okay? So mga water gani guys, i-memorize good siya. Pinaka-basic eh. Though, convenient mong paklik-paklik sa handbook in the future, but para na ako, dali na dyan ka i-memorize siya. Okay? You get the point? Ang mga basic lang good kayo. Water, air, alcohol, ice, carbon dioxide. Kaya mo siya magbalik-balik yun na siya pirmi guys. Okay, apila na lang sa ang benzene ug ang toluene. Di ba? Kaya common man kani siyang 7. Sa kanilang 7 ka substances imo siyang memorize ang mga kuan niya, mga pila mga vapor pressure at standard temperature, mga ganun. Pila iyang mga kuan, specific capacity. Sa kanilang siyang 7 ka buok. Okay, daghang kay chemicals, okay? 1,000 pila na kabuok. Basta millions, whatever, but at least nag-memorize tag 7 kabuok. Okay, kaya naman na sa libro, naman na sa handbook, imo na okyon-okyon dito. Okay, ang akong point para dili na kami okay ba kay time frame ba ang examination. Okay, memorize na lang siya. Okay, mga basta water, molecular weight of water 18.016. Ganon. Molecular weight of benzene 78.8046. Molecular weight of toluene 92.14. Ganon. O diba? Molecular weight of sugar, sucrose 180. Okay, grams per sucrose, white sugar. Okay, so i-memorize na lang gano'n mo ang mga molecular weight nga mga common yung kaistanan ha. Okay, ganon. So going back. So wata mo pugsa ha, nga i-memorize na, mas maayo gyud siyang buhaton na para dali ra ba? Okay? Okay, mo man yung mga techniques sad. Okay? Wait guys, asahin na dyan kayo siya kaya substitution na rin siya. Wait. Talo ka. Calculator please. Where's my calculator? Guys, wala akong calculator. Uy, mag-calculator ba dyan ko kay Nano? Guys, I need to use the calculator because of the exponent raised to the power 4. Oh, my brain cells cannot answer that one. Raised to the power 4. So how can I, calculate that one without the calculator? Ay, nakakaloka. Ba yan? Di pwede, uy. Di ba? Saan ba calculator? Ay, nawala dyan siya. Adara? Yes, thank you, Lord. My scientific calculator is here. Okay, now, direct substitution. Ganun siya. Okay, 27. Muna na siyang kuan guys ha. Pang substitute, you plug in the values in the equation of Stefan Boltzmann equation, heat transfer through radiation. Okay, ganun. So, 27 plus 273.15 plus 5.67 exponential to the negative 8 times 0.42 emissivity times the area. Ang area niya guys, ato lang ibuwag ha kay para i-substitute na to, ang area na gid siya nga value. So, area of a sphere, nakakaloka. Area of a sphere, 4 pi r squared. Area of a sphere. So, 4 pi r squared. This is the area of a sphere, ha? Ayaw gamita ang pi r squared. That is circle around. So, this is sphere. So, 4 pi r raised to the power 2. And r is the radius. Okay, we have already the radius, which is equal to 25 centimeter. Then, all we have to do is to convert the 25 centimeter to meter because it will never agree to the other units and it will never be cancelled. So, we need to convert. 100 centimeter is equals to 1 meter. Simple conversion in our elementary level. Okay, 100 centimeter is equals to 1 meter. Mga ganun siya chuba-chucho. Okay, 1 inch is equals to 2.54 centimeter. 1,000 millimeter is equals to 1 meter. Ganun siya ha. Okay, you get the point? Okay, 1 feet is equals to 0.3048. 1 meter is equals to 3.28 feet. Mga ganun siya chuba-chucho. Okay, 1 feet is equals to 5,280. 1 mile is equals to 5,280 feet. Okay, then 1 long ton is equals to 2,200 pounds. 1 short ton or 1 metric ton is equals to 2,000 only. Okay, 2,000 pounds. So there's a difference. But if not specified, that only mean 1 ton is the metric ton used unless specified. If specified, it's a long ton then 2,200. Okay? You get the point? Usual problems also will never mention na kung metric ba siya or short or long. It's understood that that is the standard, which is what we mean. 1 ton is equal to 2,000 pounds. But be careful. Maybe the problem in the future, it will give 1 long ton o ganon-ganon, chuba-chucho. So, another na siya. Because 2,200 pounds is equals to 1 long ton, not short ton. You get the point? So, ton, duha gyud siya ha. Ipasok sa atong brain cells. Okay, now, going back to here. So, 4 pi times radius. So, if you have the notebook, guys, di ba atong mama mo palit yung notebook, itong gabay bata. So, akong gibuhat sa una, dili ko butang sa artista, ato ko sa likod. Akong i-memorize ang mga conversion factors. Ang ganon. O, di ba? Mga ganon ako siyang hinihinayan. Okay, that was a very young age. Nag-memorize na dyan ko ang mga meter, centimeter, ganun-ganun. And as time goes by, nipilit ko siya sa brain cells until high school, until college. Di ko makalimutan ng feet to meter, gallons to liter. Okay? Di ko makalimutan na niya. 1 gallon is equal to 3.785 liters. Oh, di ba? Okay, ako naman na siyang gikuan jud, gi-memorize when I was young. Okay? At a very young age. Okay? So, ganun siya. Mapilit mo na sa brain cells. You get the point? Okay, tsaka mag-memorize ka college na late na baya kayo. Okay? Though it's okay also, but late na yun kita baya kayo ng mga conversion factors. Okay? So, ganun siya. Okay, so 4 pi r, so i-convert na to ang centimeter to meter. So, it's gonna be 25 divided by 100, right? Diretso. Okay, 25 divided by 100. Something 0.25, right? Okay, 0 naman siya ang i-divide. But we will use calculator to make sure, ha? See, 0.25 gihapon. Basta 0 ganun atong i-divide, very easy. If we multiply contains zeros, it's very easy. Move left to the right and also divide with zeros. It's very easy. But I want to make sure, that's why I use the calculator. Okay, so 25 divided by 100 is still 1.25. So this is already meter raised to the power 2. Okay, it's gonna be like that. So 4 pi. Oh my gosh, it's closely related to the, I think this is magnetic field strength unit. Wow, grabe na dyan. Yes. The unit of magnetic field strength, the value is 4 pi raised to the power negative 3 Oersted. Wow. Oersted class, grabe na kayo. Oersted is a unit of magnetic field strength. Wow. Asa man ni ma-apply ang magnetic field strength? Dito na siya ma-apply sa quantum mechanics katong mag-compute sa velocity of electrons, protons, and neutrons. Ganun siya. And the light. Okay? Katong na yung nga chupa-chucho. Okay? Lisod-lisod siya gamay, kaya di siya familiar. So, stick lang ta sa katong mga conjure. Okay? Ito na mga basic lang yun siya. Okay? So, 0.25. Okay? So, sa'yo, atong ulo mo, sakit sa kadaghan, di ba? Pero sige lang, anak mo dyan ng life. Okay? Really, daghan na dyan kayo ba, mapasok sa brain cells. So, time is equals to times 3.1416 times 4. Okay? Kung may calculator, guys, ha, ang pi 3.1416, yun na siya, ha? Okay? Wata nag-memorize na pag-elementary, nag-memorize ko na sa high school. Okay? Ang pi 3.1416, yun na siya pirmi. Okay, we have 0.7854. Area is squared method, ha? So, ang kaning area na to, guys, na nakuha na to diri-ari, nga 0.7854 squared meter, i-substitute ni mo diri-ari sa area sa katong na emissivity. Okay, ganon. Na makancel sad ang meter niya, o klaro kaayo, oy. Wow. Okay. Oh my gosh. So, di ba, makancel nimo ang Kelvin, makancel mo ang matter, what will left here is the joules, and joules is the unit of energy. Okay, if the question in the future examination will say, what is the standard and basic unit of energy? Your answer will be joule. Okay? Not calorie, ha? Because sometimes also they will trick you to be like that always, and you are known a lot of, a lot of unit. So, ang question ba, standard or basic unit of energy. So, your answer will be joules, joule. Dili siya calorie, dili siya British thermal unit, dili siya erg, okay, and dili siya watts, okay? You get the point? It's always joules. G-O-U-L-S. Okay? Kaya naman kayo nga nga question sa theory. Okay nga, what is the basic unit of ganan? Okay, so you should remember also like this, okay? Para sa mga metric system. So what is the metric system unit of time? So seconds ang answer nga na ba? Okay, pwede mo sa minutes, hour. But the question also is standard man and basic time unit in metric system. Daya seconds man yun siya. Okay, sa length pod meter pod siya imong answer, ha? The standard and basic unit of length in metric system, meter pod siya, dili centimeter. Okay, so meter, seconds, ganun siya. And sa temperature pod Kelvin. Okay, sa metric. Imo na siya timan-an. And then the mass will be kilogram. Okay? Kana siyang upat, timan-anan nimo siya. Mo na siya ang pinaka-basic unit nga pero ning gamit-gamiton sa mga equations. So, if the question will say, what is the standard or basic unit of mass? Tangan na dito, A, pound, B, kilogram, B, gram. Ganan. Di malibog din ka. Kasi na question na, A and B only, D, none of the above. Bitik-bitik din ba? So, the answer will be in kilograms. Okay? Muna siyang hitabo. Okay? So, ato siyang i-exponent to the 4 half. So siyang i-add. And then raise to the power of 4. Okay. 27 plus 273.15 is equals to raise to the power of 4. How can we do this? Oh my gosh. Okay. So kini siya. X to the 4. Let's try ha. So let's say 2 raised to the power 4 is equals ano siya 64, right? So i-try na to siya. 2 exponent to the ano siya 4. So 2 4 times 2. Okay, sakto siya. Kani siya may kuha x sa calculator. Ang x raised to the power square nga gamay, mo na siya ang raised to the power sa number niya na raised to the power 2, raised to the power 3, ganun siya. Kaya may daghan ra ba diri ari o maglibog ka. Okay? So, muna siya ang gamito sa calculator. So, 27 plus 273.15 is equals to raised to the power 4. Muna siya, laoy, taas kaayo. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. 8.1 times 10 to the 9. Okay, muna na siya guys ha. And then times 0.42 times 0.875 na katong sa area niya. Okay, 0.7854. So, pila ni siya. So, times 0.7854 times 0.42 is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.68 times 10 to the 9 ang imong heat. Okay? So, the unit will be in joules. Muna na siya, guys. Okay? Okay, 4 pi r squared man. Ito man ang i-compute na mauna siya. So, atong heat will be 2.68 times 10 to the 9 joules sa sphere. Okay, but we should remember also, class, that, you know, for the statement is in here that it should be, what is the heat energy leaving the sphere? Leaving the, guys, leaving meaning to say, you know, negative. Okay, leaving man siya. So meaning to say, it was being released, so negative. So exothermic reaction. So our 2.68 times 9 is the negative. Okay, negative ni siya. Muna siya ang tricky nga part. Okay, because when you use this equation, it will never yield a positive answer. So theory lang siya, nga ni-leave siya, it will become ano ba murag muna siyang lisod usahay gyud sa mga examinations. Okay, apilon mo lang ana good ang mga movement, mukalit lag negative, positive niya ika-substitute nimo dito sa equation, dili ba negative. Imo ra siyang analyze nga, kay nisaka man siya, niubos siya, negative siya, niubos na siya. Di ba tanan muna ana, okay? You get the point? So man na siya, leaving man siya so negative, exothermic reaction. So himo na siya ang heat. So meaning to say guys, heat released. Heat released from sphere to the room. Okay, system man ang sphere, okay, process, surrounding ang room. Mo na siya permi guys, system and surrounding is equals to the environment or the whole process in its environment. Mo ang siya permi, system plus surrounding. Okay, mo na permi ba sa physics? Okay, nag-involve na siya physics galore. Okay? Now, the second question will be, what is the heat energy for the sphere, ha? So, we need to see, for the sphere, iyang gipasa dito. So, it is the room na. Same equation, but we will substitute the 21 degree, 21 degree Celsius. So, ilista na po din mo siya 21. Okay, ganon. So, inikailis ni mo guys, pila naman siya may tabo ni Amy. Okay, so 21. Doon rin siya, kay 21 or mag 27, right? So, 21 plus 273.15 is equals to raised to the power, charalat, 27 plus 273.15 raised to the power 4. Okay. 4. Ganon. Lo, 10,000. Saka muna, 21 plus 273.15 equals to, ganun. Dili, oy, nawa, 27 plus 273.15, okay, times 300.15 times 300.15 times 300.15. Oh, sakto siya. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8.11. But positive siya, guys. Ang sa room. So, the heat released from the room or absorbed by the room. Diba? Kaya ni-absorb ba ang room? Ni-absorb ang room at the same time, ni-release siya dito sa kuan, sa sphere. Ang sphere sad, ni-release siya sa room, mo-absorb siya sa room. Equilibrium man gyud siya. Nga na man gyud siya. Oy, thermal equilibrium, di ba? Okay. So, positive pila man siya, guys. 8.1 times pa din mo siya sa kuan mga chuba-chucho. Times 8.11 exponent to the, di ba? 9. Then times kuan. Okay, 21 plus 273.15 is equals to exponential 4, di ba? Times 0.7854 times 0.4. Loy? Nagdanghag lang. 21 plus 273.15 exponential to the 4 times 0.7854 times 0.42. So, kuan siya, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 2.447 times 10 to the 9 joules. Okay, ang question sa letter C, guys, kay kuan ra ba, guys? What is the heat content in the process? So, ingani ganin, guys, heat content, imo na siyang i-add. Okay, heat content man siya. Dili man siya heat difference, ha? Dili siya heat difference, heat changes, heat loss, gradient. So, if we mean about heat content, the totality. Okay, so meaning to say, guys, we need to add the exothermic plus endothermic and the two values of the sphere and the room. So, pila man ni siya? Ang gano'n, di ba? So, muna siya mahitabo karon. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ba po siya, no? Okay? So, i-add mo, ana. Ano na yung mahitabo? Okay? So, atong i-minus 2.68 raised to the power 2.68 raised to the power 9. Okay, minus 2.47 exponent to the 9. It's gonna be 1, 2, 3, 4, 5, 6, 7, 8. So 2.1 raised to the power 8. Answer niyan. So 2.1 raised to the power 8. Joules ni siya, guys. 2.1 times 10 to the 8 joules. But then, ang answer na to dito is watts. Ato ni siya convert. Right? So, 1, masam itong giingon mo, di ba? 1 watt is equal to joules per second. So, ganan. So, joules. So, per second is equals to 1 watts. So, cancel. So, this is watt per second pa siya. Okay? So, more day gapon, pero watts per second siya. Times 10. So, kung watts per second siya, guys, sa equation number 3, namutala ba siyang time? How long will it take for the sphere to lose 1 times this joules? Imo na siyang i-conversion factor. Okay, so para makancel siya, tika muna. So joules siya, so joules times gano'n chuba-chuchu. Okay, imo siyang i-divide. Right, so 2 point something man siya, no? 2.1 times 10 to the 8. Then joules per second. Atong klaro mo din. Okay, 2.1 times 10, 8 joules per second. Inaaman tayo, what's the other way given na 1 times 10 to the 6 joules of energy. What is the time? So it's gonna be, we need to convert this one as 1 times 10 to the 6 joules. Gano'n siya chuba-chuchu. Okay. Then, gano'n siya. We need to multiply this by 2.1 times 8 joules per second. Or joules second. Cancel, joules. Ano siya, baliho na to. So 1 times 10 to the 6. So 1 exponent to the 6 divided by, okay, divided by siya, 2.1 exponent 8. Pila siya. So ang answer is 4.76 times 10 to the raised to the power 3. Okay? So ang muna mahitabo. Okay, times 2.1 joules second. So cancel. Ang muna siya nahitabo. So 4.76 times 10 to the 3 ang time. Okay? Muna siya. Nga 3 o 4.76 times 10 to the negative 3. Muna siya ang time to the 3. Okay? So meaning to thousands. Okay? Ganun siya. Saan na siya, di ba? Okay, so magbantay lang dyan ka sa conversion factors. Okay, mara gina siya mong timanan guys. Okay, because heat transfer through radiation. Wag gina siya ha. Sa ganito, okay, Q is equal to the emissivity times the 7 Boltzmann constant, which is equal to 5.67 times 10 to the negative 8 watts per meter squared. Okay, Kelvin raised to the power 4 times the area times the capital T raised to the power 4. Don't forget the area because it matters a lot. Okay, if you don't include the area, then how can you cancel the meter squared after that one? So because since we know that heat joules only is the unit. Okay, now if time will be asked, then remember the conversion factor of watts. 1 watt is equal to joules per second, or you should remember the formula of electrical energy. Okay, power or electrical energy is equals to work over time. When we mean of power, specifically what we mean is electrical energy because we are using watts. But if we will not use watts, so this P can be referred to another also energy. It depends on the situation. For example, calorie per second, joule per second, erg per second, BTU per second. But in this case, watts man siya. So watts per second, that means electrical energy or electrical power is the energy what we mean here. Okay, meaning to say, this power here is general. It could be applicable to any types of energies. It could be chemical energy, potential energy, kinetic energy, geothermal energy, radiation energy. General siya na may unit siya ng mga energy. But in here, kay watts man ang gibutang sa problem, so, this is, mana din ka, electrical energy ni siya, or electrical power, something like that. Okay, guys? Because power is not limited by to electrical. Okay? Pwede sa ubang mga chupa-chuchu. Katong mag-move kag black in an inclined surface, di ba? Kinumdum mo. Okay, na fraction, angle of inclination, moving black A to black B in an inclined, surface 30 degrees, ang gano'n. So, mo to siya lahi to siya nga kuan pero maura jud ang mga unit. Okay? You get the point? So, dili siya applicable dito ang electrical energy. Wabi kuan dito, di ba? So, dili importante dito ang time. Okay, kuan naman jud siya dito. Work is equal to force times distance cosine theta. Ganon. Ganon naman siya yung mga angle-angle chuba-chucho kay inclined man siya. Pero kung wala siya yung angle, wala siya inclined surface, ana ra gyud siya ang work. Force times distance. Ganon. Okay, but kung nanay mga mga incline kuan, chuba-chucho, gamitan din mo Pythagoras theorem ha. Okay, imo din i-account ang kuan, ang coefficient of fraction. Okay, ini ka move nimo sa block or any objects in the surface or let's say a ground or a floor, there must always be fraction in it. Okay, fraction, the opposing force. Okay, that is a fraction, opposing force that serves as a resistance or resisting force. Okay, to counteract. Okay, so we need to say this resistance or friction is a negative force. It will counteract always when there is an applied force. Okay, mo na mag-review ni katong FBD, free body diagram in the compute sa physics when you compute for the forces, the net force, chuba-chuchu, like this. Okay, ganon. So maor sa dani pero depende man sa situation kay electrical no siya, electrical energy or ganon siya chuba-chuchu. Okay, mas mga watts ha, adyo kuan na ng mga ana. Naraban siya sa board exam. Short ko. Okay? Ang mga watts na unit. Okay, guys? So it's very clear now. So thank you so much for watching this live streaming regarding heat transfer. Actually, I want to vlog mass transfer, but you know, my problem's lost. Oh my gosh. Okay, guys, thank you so much. Bye-bye, everybody. God bless everybody. Ganun siya. Okay. Hi, Maricel. Thank you so much for watching. Marcel Cabral is not sleeping yet. She is watching right now. Oh my gosh. Thank you.